3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at SpinLaunch's plans for the future. SpinLaunch is a company, and the idea of flinging payloads into space using an orbital accelerator seems to be quite the controversial topic among many. This being said, SpinLaunch is confident in its design and this unique future of accessing space. For years now, the company has been working on different prototypes and testing a suborbital accelerator, in addition to other test articles. While these tests have had some success, the company knows that making the jump to orbit is very significant, and they still have a lot of work ahead of them. Specifically, SpinLaunch has a good idea of how they plan to achieve this feat with the use of an orbital accelerator. According to the company, it would provide a velocity boost expected to drive results, including a 4 times reduction in the fuel required to reach orbit, a 10 times reduction in cost, and the ability to launch multiple times per day. If the accelerator itself wasn't ambitious enough, SpinLaunch's first customer launches are planned for 2025. This brings up the question of, is this technology even possible, and if so, will SpinLaunch be capable of creating it? Here I will go more in depth into the progress the company has made, and look closer at the orbital accelerator, meant to change how we access space. SpinLaunch describes the orbital accelerator as the world's first space kinetic launch system, and is confident that the future of space is electric. The company highlights that the SpinLaunch orbital launch system is a fundamentally new way to reach space. The velocity boost provided by the accelerator's electric drive results in a 4 times reduction in the fuel, a 10 times reduction in cost, and the ability to launch very often. Their goal is to make space more sustainable. SpinLaunch believes that with industry plans to launch 10 times the number of satellites over the next decade, it is more urgent than ever to develop environmentally sustainable space access technology. Because kinetically launched satellites exit the stratosphere without a rocket, SpinLaunch enables a future in which constellations of satellites and space payloads can be launched with zero emissions, in the most critical layers of the atmosphere. In a future where large numbers of people are traveling to space, structures, equipment, and supplies required to support in-space civilization must also be launched. For tens of thousands of people to someday work and live in space, millions of tons of infrastructure and supplies must be launched. SpinLaunch ensures that can be done with the least environmental impact possible. All of which comes back to the orbital accelerator itself. While the company has not yet built an orbital model, they have a set design in which they provide graphics and different animations. Starting with the vacuum chamber, this steel cylinder is expected to measure around 300 feet in diameter. The low-pressure environment allows the tether to spin at nearly 5,000 miles per hour, with minimal aerodynamic heating and drag. Next, you have the hypersonic tether, which spins within the chamber. Specifically, made of high-strength carbon fiber, the tether is spun up to launch speeds by a central electric drive. The launch vehicle, which carries the satellite through the atmosphere and into orbit, is attached to the end of the tether. Once the launch speed is reached, an automatic sequence releases the launch vehicle at the exact time to send it through the exit tunnel with high precision. Finally, you have the exit tunnel. Here, ultra-high-speed airlock doors, that operate faster than the blink of an eye, prevent the vacuum chamber from repressurization after the launch vehicle is released. Looking at the payload itself, it features a first and second stage, with a payload at the top. SpinLaunch is optimized to launch constellations of large numbers of satellites at a low cost. The first-generation launch system is designed to launch satellites weighing up to 200 kilograms. Following best design practices developed by the Space Systems team, they are confident most satellite architectures can readily be adapted to operate in SpinLaunch's unique launch environment, fully encased in a shell built to withstand the forces applied to it during the spin and launch process. This is SpinLaunch's current plan for the future of accessing space. Now that we know exactly what SpinLaunch is working towards, we can take a closer look at what they have managed to complete at this point. SpinLaunch started development in early 2015. Less than 2 years later, SpinLaunch surpassed the record for fastest rotational tip speeds, and subsequently conducted hundreds of launches in its headquarters-based laboratory. In October 2021, the first launch of the suborbital system validated the technology and marked a key milestone. The suborbital accelerator is designed to operate from 800 to 5,000 miles per hour, and acts primarily as a test bed for the orbital launch system. On October 22, 2021, their first launch successfully propelled a test vehicle at supersonic speeds, and ended with the recovery of the reusable flight vehicle. Throughout 2022, the system will conduct regular test flights with a variety of vehicles and launch velocities. The suborbital system offers testing capabilities to customers and provides long-term value as a satellite qualification facility. When it comes to technology like this, there are a lot of questions. One has to do with the stress of this high-G environment. They point out that during the early feasibility analysis of SpinLaunch's global architecture, one area of primary interest was G-hardening. As such, an in-depth evaluation into existing industry examples of high G-capable sensors and systems was undertaken. Early research identified promising examples of complex high-G systems in industry, including artillery-launched drones with deployable wings, propulsion, and optics. Following the completion of the 12-meter prototype, a system capable of testing to over 20,000 Gs, SpinLaunch's engineering team began evaluating a variety of hardware packages at 10,000 Gs that components endure during the launch. Through this testing, they have been able to demonstrate the impressive ability of satellite systems to readily handle the centripetal environment. The company highlights that modern carbon fiber and miniature electronics are the most relevant reasons why SpinLaunch has not been possible until recently. Carbon fiber emerged as a high-strength composite in the early 1960s, and only recently transitioned from limited aerospace applications to widespread industrial usage. Low-cost, high-strength-to-weight materials like modern carbon fiber are a critical part of what makes SpinLaunch possible, while modern electronics, materials, and simulation tools allow for satellites to be adapted to the kinetic launch environment with relative ease. In terms of the heat generated, in the 1960s, the High Altitude Research Project demonstrated that large complex launch vehicles could traverse from vacuum to atmosphere at speeds of Mach 6. While the vehicle isn't damaged by entering the atmosphere, they have designed it to survive the temporary high temperatures generated as it exits the atmosphere. The tip of the launch vehicle acts as a heat sink, absorbing any aerothermal loads experienced during flight. The heating load is less than that of other industry examples of high-speed flight. Lastly, when asked about a sonic boom, SpinLaunch pointed out that it does not have a higher sonic impact than a traditional rocket lifting off. During launch, a short-duration sonic boom is projected outwards and upwards, along the trajectory of the launch vehicle. SpinLaunch uses industry-standard methodologies to evaluate and comply with the Federal Aviation Administration's requirements for noise profile analysis, the same as traditional rocket launches. As of right now, SpinLaunch's suborbital launch site is located at Spaceport America in New Mexico. The first orbital launch site is in final selection in a soon-to-be-disclosed location in a coastal region of the United States. They are closely collaborating with the FAA and other governing agencies for launch site licensing. We have seen multiple tests over the last few months alone showing decent progress. This being said, there is still a very big difference between the current suborbital tests and the plans for an orbital future. Many people are very skeptical of what SpinLaunch is working on. As of right now, they are working hard to try and create unique technology meant to change how we access space. For years now they have been testing different models and gathering information. The company is very confident in its future and the ability to reach orbit using an orbital accelerator. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.